Hi everyone, we're back again for another MERA tutorial. My name is Tom Carruthers, and right now I'm going to talk you through how to do MERA's Status Determination Mode. I'm just going to call up the manual again so we can just see where we're at in that schematic and how Status Determination Mode fits in. So if you remember, in the first step to MERA, we defined this quantitative questionnaire, which created an operating model, a system dynamics model for testing ideas about management in a fishery. And based on that questionnaire, the operating model was built, and we've, in the previous tutorial, talked about how to do management planning mode. That's a mode where we test, in theory, the performance of different management procedures. But now we're going to skip management performance mode and go straight to status determination. And to do this, we require some data. So what we're going to do is we're going to take all the things that we specified in the questionnaire, so all our best available knowledge of the system, and we're going to combine that with data. There's this down arrow here and this arrow around the side to estimate what the stock status is. Okay, so to do this, let's go back to the MERA app. As we've just said, we've got to load up some data. So let's start off by loading the MERA example that we just did, Tiger Flathead. So that loads the questionnaire. We go, it's already been filled out, but now we go to the data section and we load a data file. That is a CSV data file. Let's open that, and that loads that into our session. Now, we might want to have a look at what that looks like. So let's see if we can open this in. So here's, if I just move this to the screen, this is what this CSV data file looks like. I'll just zoom in for you. It is looks very much like a spreadsheet, and it essentially has a sort of field down the A column and then values entered into this B column over here. And the data file itself covers all things from growth and biological parameters like natural mortality rate and things like that, including uncertainty in those. But it also includes time series data. Here, starting in 1915, there's a series of catch data. The exact formatting of this is available also in the manual. So you can work out how to do this exactly, but it includes catches, indices, mean length, catch at age and catch at length. And the way that all this data fits together is fully documented. But that's just to give you a quick idea of what a CSV data file looks like. It's much easier to actually work with some examples from the actual manual. Anyway, there's a glimpse as to what that is. One of the first things you can do when you've loaded it into MERA is just build the data report. And this is a standardized HTML markdown report, which is going to tell us exactly what our data look like. And so this is just a sort of description of the thing we just loaded, showing you some of the biological parameters up here. So these are the distributions for things like natural mortality rates and length at 50% maturity. It'll also show you what the implied growth curve is like for this particular fishery, this particular fish. It'll also show you some of the selectivity parameters and what they tell you about selectivity at both age and length and so on, including catch series showing you the catch and the indices that were used. So this is just like a sort of neat little report that you can build and share with people to sort of describe your data. Now, there's two ways of doing this. One way would be to go to options, choose status determination mode, and then come all the way down here and essentially just push calculate. And what that'll do is condition the model, i.e. fit it, much like a stock assessment model, to the data that you've provided. We're not going to do that because I want to talk you through the settings menu. Now, all of the controls that are required to fit a MERA operating model to data are actually in the settings menu, and they're all down at the bottom down here, operating model conditioning. First of all, we're going to just do a couple of things. One is we're going to increase the number of simulations to 32. This is a very low number, but the whole purpose of it is to provide us with enough that if some of the fittings don't work, they don't converge, we still have some left over for this demonstration. The next thing we're going to do is make sure we do all our calculations using parallel computation. Because when we're fitting these essentially what is 32 different stock assessment models, we need to make use of all the processing power on the server to do that. We want to use the conditioned operating model. So this is the bit that checkbox actually says. We're not just going to use the MERA questionnaire. We're going to use this conditioned operating model. The other things down here basically ask us whether we want it to solve for the Baranov equation or actually estimate fishing mortality rates as leading parameters. So this is really just a technical thing that if you have difficulty, you might want to check it. Another thing we could do is assume a certain rate of equilibrium catches. So this is before we've got data, we can ensure that the model spools up, assuming some fixed rate of catch before that initial time. And that can be useful in situations where we don't have a long time series of data, but we have an idea of how much catch was taken, roughly speaking. And that will start the operating model off at a somewhat depleted state. We don't need to do that here. The only other thing to really worry about here is the conditioning model. And you'll see that whenever you click on some of these things, it gives you some guidance. And just so you know, these are labeled after the types of data that are available. Now for Tiger Flathead, we have catch, effort, a relative abundance index, and length composition data, represented here as CEIL. The standard way of conditioning models is not to use the effort, and it would be to use the catch, the index, and length. So that's the default approach we're going to use here. And I think at this point, we've specified everything we need to. The only other thing you need to know about is down here. The maximum number of independent composition samples, this thing here, is telling you how, or the approximate weight of the composition data. Here, it's that length comp data. And the default here is 100, but you can play around with that to have the model fit the composition data to a greater extent or not than, for example, the index and catches. And here's another way of dealing with that is just actually alter the weight of the negative log likelihood for the composition data here. So this is another way of achieving the same thing. And another setting here is the apical F. So this is the most selected age class. And the question is here, how high should that maximum be? And 3 is roughly speaking 95% harvest rate. So that's saying for the most selected age class, you can't catch more than 95% of the fish there. And you might want to lower that or increase it depending on your case study. But this is quite a high limit. Once we've done all of that, we can just condition our operating model by clicking Make Operating Model. At the same time, we could just put Calculate at the bottom of Status Determination Mode. It does exactly the same thing. So now what's happening is somewhere in a room, a server is getting very hot, calculating 32 different stock assessments at a time. And it's doing those fits. For each one of the simulations, it does a fit. So this is kind of a Monte Carlo approach. It takes 32 realizations from the questionnaire, and for each one, it tries to fit with those assumptions, tries to fit to the data that you provided. And the idea here is to allow the data to help you define a more empirically plausible operating model, one that's consistent with the historical data. So the very observant people amongst you will notice A, that it's finished running, and B, the number of simulations has dropped from 32 to 26. Okay, so what's going on here? Well, if we go down to the log down here, let's go all the way to the bottom, our log tells us that 26 of the 32 simulations converged. So the rest have been ignored, and that's why the simulation number dropped down. When we ran this thing, it automatically ran status determination mode. But probably the first thing you would want to do once you've conditioned an operating model is go to reports and have a look at the detailed fitting report. So let's click on that. And what that's doing is producing a report very much like something you get for something like stock synthesis or Woods Hole assessment model, WAM, or something like that. It's a standard set of diagnostics that tell you how well the model was fitted, which data it fitted well, what the likelihood components were. So let's go take a look at that. So this is it. So the RCM output is split up into various headings across here, including how the parameters are now estimated, things like the initial recruitment here. It also gives you plots of recruitment over time, spawning stock biomass over time, and selectivity. In most of these plots, you actually see a line for each simulation. You can see some of these varying a lot between the different simulations, the 32 or in fact 26 simulations that we had. And this shows you the fit to the index here. So all these red lines are individual simulations fitted to the index. You could see model predictions by, for example, spawning biomass and depletion for each of those simulations. Another thing you could do is go to the mean fit panel. And that shows you what the fit to the mean input parameters were. So this is a separate fit with a bit more detail, because there's only one of them, about how well the mean parameter fit went. And you can't really show this for all 26 of those simulations, but you could show it for one. And this allows you to see what the likelihood components were for the various data types, the parameter correlation matrices and likelihood gradients and things like that. So this gives you a huge amount of information about how well the model fitted the various data you've got. And it's pretty much consistent with what most stock assessment models would provide you with. We could go in for hours about this, but there's a lot more information about this on the SAM tool website, and also in the MERA manual. There's links to greater guidance on how to interpret the outputs of the fitting report. But let's assume that we think our conditionings happen satisfactorily. We've looked at that report and we've said, well, okay, this is a reasonable representation of the system that we filled out in the questionnaire, and it fits the data really well. Okay, great. So the first thing we're really interested in is stock status, and the most simple outputs of this are provided in status determination mode down here. The first is a box and whisker plot showing you what the spawning stock biomass today is relative to the historical level. So this is the depletion here between about 50% and 30% of the unfished spawning stock biomass in the initial year. And coupled with that box and whisker plot for today is a table just telling you what the probability is of the spawning stock biomass being above various fractions. And here, for example, a roughly 50% probability of being above 40% of SSB0. You also got a plot of the various ranges of outcomes across the simulations here. So essentially, the box and whisker plot here and the table is this most recent year, but this is what it looked like historically. And this is showing you a stock trajectory. And actually, in this case, substantial rebuilding from a low level in around 1960 or thereabouts to this current level, which is about 40% of historical levels. So this is a very simple output that you get, but it's the principal output of status determination mode. And of course, you can get into more detail in the actual conditioning report. But for now, this is the most basic and sort of fundamental output that comes from this particular mode. Of course, you can formalize that in a report also. And this one summarizes the results of exactly the figures you've seen. So there's also a report for status determination mode. And of course, it looks exactly the same as what you just saw. That's actually the end of this very brief tutorial about status determination. The fundamental difference between this and previous approaches is this idea of conditioning the model. One thing I will tell you is that if you go into any of these modes, any of them, management planning, management performance, status determination, if you go into any of those modes and you've loaded data and you've selected conditioned operating model, it will automatically, if you haven't already, it will automatically condition the operating model. So you could just do the regular planning mode, push calculate, and it will condition the operating model automatically. The only reason we did it in the menu up here is to show you what the settings were. So you can condition operating models and do management planning mode. You need to condition models for status determination mode. And you also need to for the management evaluation, performance evaluation mode. So for now, that's it. We've got our questionnaire, we've got our data, and now we have an estimate of our stock status. I hope that's been enough. And remember, you can always go back to the help file, the user guide, which will tell you all about status determination mode and how to interpret the outputs. So, okay, thanks very much, guys. And I'll be back in just a second to show you how to do the performance evaluation mode.